going to select a number, a 3-digit number, and we're going to try and find the square root of that number. We're going to select it by randomly choosing 3 numbers from this group of 9 numbers I have down here on a little piece of paper. So I put my little radical sign to represent that I'm trying to get the square root of 118. Now my strategy is as follows. I want to try and find a number which is a perfect square and that is close to 118, but that does not exceed it. And I think I have that number. It is the number 100. Yes, number 100 would just do fine. So what I'm going to do, interestingly enough, is I'm going to multiply by that perfect square 100, which is 10 times 10, by the way. And I'm going to divide by that 100. What is that going to do for us? It's just multiplying the thing by 1. It certainly is not going to change the value of this expression. I think most of us would agree about that, wouldn't we? Okay, well, I'm going to do a funny little tricky thing here. If I can find my little eraser. I'm going to bring this denominator over to my other number here, my 118. And over here, and I'm going to extend the square root sign, this radical sign as it's called, just to make sure there is no doubt what we mean by this expression. And now that I've done that, I'm going to erase this little piece because I want to change this into 2 square roots, relying on the theorem that the square root of a product of 2 numbers is equal to the product of the square roots of those numbers. And that's what I've done here. What is the square root of 100? I think we already decided that it was 10. So I'm going to rewrite this expression as 10 times the square root of 118 over 100. Well, what about that? Ain't that great? I have changed the expression here. What I'd like to do now is actually carry out this division. And if I carry out that division, I think it just comes out to 1.18. So I don't even have to carry out that division. I'll have 10 times the square root of 1.18, and we're right there. So now what am I going to do next? Well, should I just be befuddled, or should I try something? What I want to do is I would like to share a little theorem, and that is that if I have 1 and a decimal following it, but the square root of that number is approximately, actually somewhat less than 1 point and about half of this. Well, it's a bit less than that. Someday I'll share with you why this theorem is true. But if it were 1/2 of that, it would be 1.09. But trust me, it's going to be less than that. So I'm going to try 1.08. And I'm going to do this. I'm going to multiply 1.08 times 1.08 and see what it gets me. 8 8s are 64. 8 1s are 8. And I have 801. 64. 16. 116. So we finally have found a perfect square, 11664, which is 1.1664, which is close to 1.18 but does not exceed it, which is what I wanted. And what I'm going to do is I'm going to erase this stuff for a minute. And I'm going to multiply this number here, 1.185, 1.1664, and divide it by 1.1664. Then I'm going to do the very tricky thing that I did last time. I'm going to move this denominator over here, 1.1664, and which I can do. I hope you all agree on that. Then I'm going to break this square root up there, and I have two square roots, and I'm going to take the square root of this, which is 1.08. You already arrived at that earlier, so I have now, I'm going to rewrite this as 10 times 1.08 times the square root of 1.18 divided by 1.1664. Now, what I'm going to do is I'm going to evaluate this as a decimal, just as I did here. I evaluated the ratio as a decimal here. I'm going to do the same thing with this, but this time we really have only a division job to do. I think we would all agree about that. 0.165, we're going to replace this by 10 times 1.08 times 1, the square root of 1.01165. Okay, I want my estimate of the square root. I say it's going to be 1.005. That's about half of 11, which is like 10, and you know. So I'm going to do 1.005. Let's see what that gives. 4.5, 5 5 to 25, 5, 5, 1, 1.01025. There we go. 1.010.1011. Hey, that's pretty close. What do you think? Do you think that's close? I think it's close enough for us. So I'm going to do the same thing here. I got my perfect square, decimal point there. 1.010, I hope I did this right, 025 divided by 1.010.025. Shift the denominator. 1.010.025. Break up into two square roots. This we know is 10 times 1.08 times 1.005. I'm going to go through this once more, cut it short in a minute, we'll see. Times the square root of this silly thing here, 1.01165 divided by 1.010.025. Okay, so let's evaluate that as a decimal. I'm going to erase this. It's basically, we're going to rewrite this expression roughly as, we just did this division, so it's approximately 1.0016. I'm going to leave it at that, because our approximate square, I know there's going to be more here, so I'm going to call it 1.008. And I'm simply going to say we have 10 times 1.08 times 1.005 times 1.0008. Okay, basically what happened is 0.0008 is what happened 0.0016, you see? And the point is this: if this were exactly 1/6, the half rule would not follow, but usually there's some material beyond that, and that makes it possible to use our half rule pretty closely. So let's evaluate our expression for what we think is the square root. According to all of our troubles, our square root is about 10.8626. So we don't want to multiply all of those numbers, do we? No. Well, this is what I would do. Let's erase all this stuff here because I want to do calculations. I want to multiply this number by itself, but really, I don't want to do the whole thing. 10.862, 10.862. 2, 2, 4, 2, 6, 12. Okay, so we would have gotten, just including that 2, is 117.98. If we decided to include the 6 after the 2, we would have gotten a better fit. So I hope this settles the matter. I think we did a respectful job of trying to find the square root of 118. And I hope this shows you a way in which you can find your own square roots. So thank you very much for watching today.